Hello everyone, my name is Arnav and today we'll be doing the second virtual challenge meet from 2023 to 2024 of the UIL science exam. We'll be going over the 20 physics problems in this video. Before I go over all the 20 problems, I want you all to try the problems out to yourself to see where you all are at. So these are the problems from 1 through 7. These are the problems from number 8 through number 13. And these are the problems from number 14 to number 18. And then these are the last two problems, number 19 and number 20. For numbers 1, 2, and 3, each year you're going to be assigned a chapter to read for these 3 questions from a book. This year the book was 5 Equations That Changed the World by Michael Gillen, and we get all 3 of these answers from that chapter. So for the answer to number 1 would be A, Robert Hooke. The answer to number 2 would be C, 5%. Answer to number 3 would be E, Neil Armstrong. Number 4. The Blank Space Telescope was launched in December of 2021. The original plan was to launch in 2018 and to place it 1.5 million miles away from the Earth and at the L2 Lagrange point, orbiting the Sun and a fixed distance from the Sun and Earth. This is an astronomy question. The 4th question will always be an astronomy question, and you have to know that off the top of your head. There's not much you can read some astronomy books to study for it. The answer to this one would be D, James Webb. Number 5. The students on the science team at Argyle got Miss Good a special transmitter/receiver on her birthday so she can communicate with her friends on Pluto. If Pluto is 5.05 billion kilometers from Earth, how long does it take for one of her messages to reach Pluto? So, what's not given in this problem is that the transmitter is going at the speed of light. And the speed of light is 30 times 10 to the 8 meters per second. We know the distance between Pluto and Earth is 5.05 billion kilometers. But we want to convert that into meters because our speed is in meters. So 5.05 billion is the same thing as 5.05 times 10 to the 9th. And that many kilometers, if you want to convert kilometers to meters, you multiply by 10 cubed. So this is how many meters Pluto is from Earth. So now you want to do distance equals speed times time, where you solve for time. So time equals distance over speed. So plugging in our values, 5.05 times 10 to the 9th times 10 cubed over 3 times 10 to the 8th. Plugging all that into a calculator, let's see what we get. We get 16,833.33 seconds. But we want to convert that into hours and minutes. So dividing it by 60, no, actually it's at 3,600, let's do it faster. 3,600 seconds will get you 1 hour. So divided by 3,600, you will get 4.676 hours. That's how long it takes to complete the trip. But we want to write in hours and minutes. So we know it's 4 hours and 0.676 hours. 0.676. What is 0.676 hours in minutes? We know 1 hour is 60 minutes. So, plugging that into a calculator, you would get 40.56 minutes. So our final answer would be 4 hours and 41, if you round up, 41 minutes. So our answer to number 5 is going to be B. Number 6. Rochelle stood on top of Fort Bend State Bank and threw a baseball at a speed of 24 meters per second at an angle of 36.6 degrees above the horizontal. If the baseball left Rochelle's hands at a height of 28.8 meters above the ground, how far from the base of the bank did the baseball hit the ground? So let's draw the scenario. So this is the bank. This is Rochelle, and he threw a baseball at an angle of 36.6 degrees at 24.4 meters per second, and the height of the building is 28.8, and we're trying to find, after the ball hits the ground, what is this distance, x? Let's just say, in this case I'll put it as d. So we're going to need to use kinematic equations for this problem. So let's move this up a little bit, and let's use some kinematics. What is the vertical and horizontal component of the projectile? We know the projectile goes at 24.4 meters per second, 24.4, and an angle of 36.6. So finding the two legs using trigonometry, this would be 24.4 cosine 36.6. This would be 24.4 sine of 36.6 degrees, both of them. And plugging both those values in, you would get, hold up, 24.4 cosine of 36.6, 24.4 sine of 36.6. You would get 19.589 meters per second and 14.548 meters per second. Meaning, these are the two velocity components. So we're trying to find this distance. We want to find the horizontal distance. We take the horizontal velocity times time. Remember, distance equals velocity times time. So distance equals 19.589 times the time it takes to touch the ground. Well, what is the time it takes to touch the ground? We know that's the only thing we need because we already know the speed. Well, we know that the initial upward velocity is 14.548 because the ball is going up 14.548 meters per second. We know the acceleration, because of gravity, is negative 9.8. So the object is going up. The initial velocity is going up, but the gravity is pulling it down. And we want what do we want to find? We want to find it when when the ball reaches the height of 0, when it's initially at a height of 28.8. We can use a kinematic expression for this one. So we know that, for example, displacement equals initial velocity times time plus 0.5 times acceleration times time squared. This is the expression we can use. I'll move this way. So what is displacement? We know it's negative 28.8 because displacement is final minus initial. Final height is 0, initial height is 28.8. So 0 minus 28.8 is going to be negative 28.8. Initial velocity we found out is 14.548 plus 0.5 times negative 9.8 times time squared. So that's what you're trying to find with this entire expression. So plugging, forgot the t here.
So now we want to solve for t. So bringing t to both sides, you can get 4.9 t squared minus 14.548 t minus 28.8 equals 0. Using the quadratic formula, we can get, so 14.548 squared minus 4 times 4.9 times negative 28.8, square root of that, 14.548 plus the answer, divided by 2 times 4.9. Using the quadratic formula, you would get time would be 4.327 seconds. That's how long it takes for the ball to hit the ground after using the kinematic equation. Now plug that into our initial formula. So D equals 19.589 times our answer. You would get 84.766 meters. That is our final answer. So the final answer is 84.76, which is close to 84.8. So the answer to number 6 would be letter E. Number 7. The coefficient of kinetic friction between the larger block and the surface is 0.325. Assume that the pulley is frictionless. When the smaller block is released, what is the acceleration on the large block? So it's asking us in a pulley system like this. This is a pulley system. When this block over here, when that's released, meaning when it's freely able to drop down because of its weight force, what is the acceleration of the entire system? So for any of these problems, if you can't determine the answer straight up, the best thing you should do is to draw all the forces. So there's going to be a tension force. That's because of the rope. Whenever a rope is attached to an object, there's going to be a tension force that's being applied on the object. This applies to both of these objects. There's going to be a tension force. And what other forces are there? There's weight force, there's tension force. Look at the sentence here. The coefficient of kinetic friction. That means there has to be friction force. So there has to be a force of friction opposing the block's movement. And where's the block's moving? The smaller block is being dropped like this. It's going down, and the block on top is going to the right, if we follow the diagram, which is why the friction force is going to the opposite of right. It's going to the left because it's opposing the rightward motion. So these arrows represent net force. Actually, I'll draw this one in blue. These arrows draw the net force. So this would be force net, the net force in the x direction. This would be net force in the y direction. So we know that net force is the sum of all the forces. So the net force in the x direction would be tension minus friction force. And the net force in the y direction would be weight minus tension. So what is net force? According to Newton's second law, net force is mass times acceleration. So we can replace the net force x with, let's just call this mass of x, mass of y for now. I know we're given values over here, but just to make it simpler so we can plug it in later, we'll call it mass of x, mass of y. So mass of x times acceleration equals tension minus force of friction, and mass of y times acceleration equals weight minus tension. These are the two formulas that we now have. So one second, I'll move that down a little bit. These are the two formulas. We got them because of the net force equaling mass times acceleration. So what is weight force? Weight is equal to mass times gravity. And we know that in this case, the weight force is acting on the mass y. So it's going to be mass y times gravity. So weight is going to be equal to mass of y times gravity minus tension. Now, and what is friction force? What is friction over here? The formula for friction force, so I'll just keep weight force. The formula for friction force is coefficient of friction times a normal force. Normal force on an object that's on a flat surface is equal to the weight force. So this is the weight force, that's the normal force. These two would equal each other because the object is on a flat surface. So this would essentially be the coefficient of friction times the weight force, which is mass times gravity. So force of friction is essentially coefficient of friction times mass times gravity. Now, how do we solve for acceleration here? Let's copy this over. Actually, we can move everything up here. We can move tension to both sides. We can actually move tension here. For this one, for the top equation, we can equate that as tension equals mass of x times acceleration plus coefficient times mass of g. And we can plug tension into this equation. So you can get mass of y times acceleration equals mass of y times gravity minus mass of x times acceleration minus coefficient of mass times gravity. We just plug in tension here to get this value. So we want to find acceleration. So we get acceleration on both sides. So I'll just get rid of this part. We get acceleration on both sides. So mass of y times acceleration plus mass of y, mass of x times acceleration equals mass of y times gravity minus coefficient times mass times gravity. Factoring out the acceleration, we can get mass of y plus mass of x equals mass of y times gravity minus coefficient times mass of x times gravity. I actually forgot to write the x here. And finally, our final equation is going to be mass of y times gravity minus coefficient times mass of x times gravity over mass of y plus mass of x. We can plug everything we know. Mass of y is 1.15. Gravity is 9.8 on Earth. Coefficient of friction is 0.325. Mass of x is 3.02. And gravity again is 9.8. And then mass of y is mass of y plus mass of x, just which is just 1.15 plus 3.02. Plugging this entire expression in, you would get 1.15 times 9.8 minus 0.325 times 3.02 times 9.8 over 1.15 plus 3.02. You would get acceleration equals 0.396 meters per second squared. So this is the final answer to number 7. So the answer to number 7 is going to be letter A. Number 8. A loaded roller coaster with a total mass of 2,220 kilograms is traveling on a horizontal section of track at a speed of 2.66 meters per second. The section of track is 18.8 meters above the ground, and the car descends to a ground level section of track. Find the speed of the roller coaster at ground level of the section of track, ignoring friction. So, this problem relates to a conversion of energy. We know initially this track the car had a height of 18.8, and it was already traveling at a speed of 2.66 meters per second. After it falls down, we want to find the final speed. So this problem revolves around the conservation of energy, where the total amount of energy before equals the total amount of energy after. So energy before equals energy after. So what energy was before in the beginning? There was potential energy because the cart was at a height. So this cart had a height, so it had potential energy. It had kinetic energy because the cart was moving at a certain velocity. So we know the formula for potential energy is mass times gravity times height. The formula for kinetic energy is 1/2 times mass times velocity squared. Mass times velocity squared. So in the beginning, there was potential energy, which was mass times gravity times height plus 1/2 times mass times velocity squared. At the end, we know what's the height at the end. The height is at ground level, so there's no height, there's no potential energy. There's only kinetic energy. So equating E, B, and EA to each other, you get mass times gravity times height 1 plus 1/2 times mass times initial velocity equals 1/2 times mass times final velocity squared. And yeah, I meant to say initial velocity squared. We know we can divide mass from both sides, so we're going to be left with gravity times height plus 1/2 times initial velocity squared plus 1/2 times final velocity squared. Plugging in what we know, 9.8 is the gravity, 18.8 is the initial height, 1/2 times initial velocity is 2.66, 1/2, and we're trying to find the final velocity. So plugging in everything we know, 9.8 times 18.8 plus 0.5 times 2.66 squared times 2, square root of the answer. Final velocity would equal 19.379 meters per second. So 19.379 is closest to letter C, 19.4. So the answer to number 8 is 19.4, or letter C. Number 9. A 1,200 kilogram car comes to a flat stretch of road where the curve has a radius of 75.2 meters. The coefficient of static friction between the roads and the tire of the car is 0.725. Find the maximum speed the car can travel on the curve without skidding. So let's draw the curve in bird's eye view. And then this is the car. So what forces are going to be applied to the car? Just like we did in the other previous question, we want to draw all the forces that are going to be applied to the car. There's going to be a force of static friction that points to the center of the curve. This is true for any curve. Whenever a car is turning or any object is turning on a curve, static friction is what keeps it, is the force that pulls it towards the curve. So, force of static friction. And what is the general term that describes the force of a car pulling it towards the center? It's known as centripetal force. So, centripetal force. Those are forces that pull the car to the center. So in this case, centripetal force would completely equal the force of friction. So force of friction equals centripetal force. Centripetal force is equal to mass. Is equal to mass times velocity squared divided by the radius. Force of static friction equals coefficient of static friction times normal force, just like we saw in the previous problem. So coefficient of static friction times normal force equals mass times velocity squared over radius. So we know that since the car is on a surface, normal force equals weight. So normal force equals weight or mass times gravity equals mass times velocity squared over radius. Mass cancels each other out, so you're just going to get left with coefficient of friction times gravity equals velocity squared over radius. Solving for velocity, you're going to get square root of coefficient times gravity times radius. And solving for everything, so coefficient of friction would be 0.725. Gravity would be 9.8. And the radius would be 75.2. Solving for everything would get you 0.725 times 75.2 times 9.8. Take the square root of the answer. You would get velocity as 23.11 meters per second. So the answer to number 9 would be D, 23.1 meters per second. Number 10. A 44.4 centimeter long string is fixed at both ends. The mass of the string is 1.12 grams and the string is under 25 newtons of tension. Find the frequency of the fundamental mode of vibration in this string. So this is about standing waves. So in a standing wave is a wave between two solid objects. So a wave between two objects that stay in one place. So this wave will reverberate around these objects. So the formula to find the wavelength of the standing wave is equal to 2 times the length of the standing wave divided by the mode of vibration. So this would be wavelength. L would be the length of the wave. N would be mode of vibration. So in the fundamental mode of vibration, N would equal 1 in the fundamental. So with that in mind, wavelength would equal 2 over L. So length is, and in this case, length would be equal to 0.444 because 44.4 centimeters is 0.444 meters. So the wavelength would be 0.888 meters. That's the wavelength. We want to find the frequency. We know the frequency. We know another formula we need is wavelength times frequency equals velocity. So solving for frequency, you get frequency equals velocity over wavelength. We actually found wavelength already is 0.888. We want to find velocity. The formula to find velocity is going to be the square root of tension divided by linear density, which is mass divided by length. So these are the 3 formulas you're going to need to know if you want to solve this problem. So velocity would be equal to square root of the tension is 25 newtons divided by the mass, which is 0.0112 kilograms, because the mass has to be in kilograms. Actually, wait, hold up. It's even 0.00112 kilograms divided by the length of the string, which is 0.444. So this is going to be the velocity of the string. So solving for that, the velocity would equal 0.00112 divided by 0.444, 25 divided by all that, square root of the answer. You would get 99.553 meters per second. Plugging that into the equation that we found, frequency would equal 112.109 hertz. So the answer is going to be 112.109 or closest to letter B. So the answer to number 10 is going to be B. Number 11. A helium balloon needs to be filled with enough helium to lift a total load of 64.7 kilograms. What is the required volume of the helium balloon? So we have a helium balloon carrying a load of 64.7 kilograms. So for these physics problems, we always want to draw out the forces. There's going to be a weight force because the load has mass. Because the load has mass, there's going to be weight. There's going to be a buoyant force because this helium balloon is in a fluid. The fluid is known as air. And we remember, fluids doesn't have to be liquid. Fluid can mean liquid and gas, liquid or gas. So air is a gas, so there's a buoyant force. The air exerts a buoyant force that counteracts the weight force. But there's actually one more force that's being applied. It's the weight of the helium. So, weight of the helium. When you add helium to the balloon, the hot air balloon, even the helium has weight to it. So that weight would have a weight force. So the buoyant force has to equal the weight force of the load. Yeah, WL would be the weight force of the load plus the weight force of the helium. Because we want to find the required volume of the helium balloon. You could say, another way of saying that's the minimum volume you need. That's just the bare minimum you need for this balloon for the buoyant force to equal the weight forces. So the balloon could stay stationary. Any more volume and the buoyant force will exceed the weight force and the balloon will go up. So this is the equation you want to solve. What is buoyant force? Well, remember, force equals pressure times area. Pressure equals force times area. And we know force. Force equals pressure times area, and pressure is equal to my bad. Pressure equals force divided by area. That's the right equation. Force is equal to mass times gravity, mainly because of weight force, because that's what the force we're dealing with here. And area just stays the same. Another formula you're going to need to know is density of the object equals mass divided by the volume. So remember, capital P is pressure, lowercase p is density. So rearranging the equation, mass equals density times volume. Over here, density times volume times gravity divided by area. And volume divided by area is the same thing as there's going to be a singular dimension, which in this case would be height. So pressure is equal to density times gravity times height. This is a general equation you're going to need to know for any hydrodynamic problem. So let's just move these over here. So we know pressure. Remember, force equals pressure times area. So when we undo that expression, height times area is considered volume. So you're going to get something like this. So buoyant force is equal to the density of the fluid times the volume submerged in the fluid times the gravitational constant. This is a formula you will need to remember. So buoyant force, what is the density of the fluid? We know the fluid is air, so the density of air is 1.29. What is the submerged volume? That's what we're trying to find. And gravity is 9.8. What is the weight of the load? Let's get rid of this. What is the load? The load is going to be 64.7 kilograms times 9.8. Because we're trying to find the weight of the load. What is the weight of the helium? Remember, force equals mass times gravity. Weight equals mass times gravity. And mass equals density times volume. So we're trying to find the density of the helium times the volume times gravity. So density of the helium is given to us as 0.18 times volume is what we're trying to find, times gravity is 9.8. We can divide gravity from both sides, 9.8 from both sides. You can get 1.29 times submerged volume equals 64.7 plus 0.18 times submerged volume. So now solving for submerged volume by getting it to one side, you're going to get 64.7 over 1.29. I'll draw this over here. Submerged volume would equal 64.7 divided by 1.29 minus 0.18. This would equal, so 1.29 minus 0.18, 64.7 divided by the answer is going to be 58.288 meters cubed. This is the final answer. 58.288 is closest to 58.3. So the answer to number 11 is going to be E. Number 12. Find the current in the 60 ohm resistor. So we're trying to find the current in this resistor. So we're going to need to use Ohm's law, where voltage equals current times resistance. In this case, we want to find voltage equals current times total resistance. So to find total resistance, let's first start with this part of the circuit, which I'm going to do in blue. When we're dealing with resistors in series, remember, this resistor 1 and this is resistor 2, to find the total resistance, you add the resistors. So in this case, this total resistance would be equal to 75 plus 45 is going to be 120 ohms. So another way of writing that entire part would be, you would have 60 ohms here, 120 ohms here, and you would have this segment would be 120 ohms. Now, we know these two form a parallel circuit because the resistors are parallel to each other. They're on parallel lines. They're on parallel circuits right here. So in a parallel circuit, so let's just say something like this. If you have resistor 1 and resistor 2, to find the total resistance, you use this formula. The reciprocal of the sum of the reciprocals of the resistors. So doing that for this one, 1 over total resistance equals 1 over 120 plus 1 over 120. Total resistance would equal 60 ohms. So we can eliminate this. Instead of having two 120, 120, we can just have one 60 ohm resistor. And once again, these are in a series circuit because they're in a straight line. So you simply add them up. 60 plus 60 is going to be 120 ohms. So the final resistance is going to be 120 ohms. We know the voltage of the battery is 90 volts and that the total resistance is 120 ohms. So 90 equals current times 120. Current would equal 0.75. 90 divided by 120, 0.75. Now, that's the current going through the circuit. So the current goes from this. We know that since 60 is series, in a series circuit, the current stays the same throughout. So the answer would be C, 0.75. Number 13. A point charge of 800 microcoulombs is placed at A, and a point charge of negative 600 microcoulombs is placed at B. Find the magnitude of the net electric field at point C. So let's go over a bit about electric fields and point charges. When you have a positive charge, positive charges generate electric fields away from themselves. So they generate electric fields away. Negative charges, on the other hand, generate electric fields toward themselves. So they generate the fields toward themselves. So that's the key difference between positive and negative charges. So point A is a positive charge, so it would generate, point A is a positive charge, it would generate an electric field away from itself. So all the way to point C, it's going to generate a field away from itself. Point B is a negative charge. It would generate a field toward itself. So all the way to point C, it would generate a field toward itself. So we're trying to find the net electric field. So there's a red electric field generated from point A, and then a blue electric field generated from point B. So let's find the electric fields between point A and point B. The formula for an electric field is equal to the electromagnetic force divided by the charge of the point. So Q stands for charge. Charge is measured in coulombs. F stands for force, the attractive or repulsive force, newtons. While E is the electric field. In newtons per coulomb. And another formula you're going to know is Coulomb's law, which states the attractive force between two point charges. So if you have one point charge with a charge of capital Q, another charge with charge lowercase q, at a certain distance r units from each other, they're going to have an attractive force of F. Or if they have the same charge, they'll have a repulsive force of F. So if they have opposite charges, they have attractive forces. And if they have the same charges, they'll have repulsive forces. So what if we had plugged this part into F? We get electric fields equals Coulomb's constant times the charge divided by the r squared. So this is the equation we're going to need. Basically, when you have a charge and you generate the electric field, and then you have a certain point r distance away from the charge, the electric field at this point, there's going to be a certain value of the electric field generated at that point. This equation will generate it. So how are we going to use this for the question now? Well, what is the electric field generated from A to C? Because we want to that's the red electric field we're trying to find right now. The electric field generated from A to C. The formula to find electric field is just Coulomb's constant times the charge. The charge at point A is going to be 800 times 10 to the negative 6 coulombs. Because this is microcoulombs. Micro means 10 to the negative 6. 10 to the negative 6. The distance between A to C is 100 centimeters, because 80 plus 20, 100 centimeters is just 1 meter. What about the electric field from B to C? Coulomb's constant times 600 times 10 to the negative 6 divided by, what's the distance between B and C? From B to C is 20 centimeters, so 0.2 meters squared. You're going to get, and remember Coulomb's constant is equal to 8.99 times 10 to the power of 9. So we're trying to find the net electric field. So the electric field the net electric field is equal to the magnitude of the electric field from AC minus the magnitude of the electric field from BC. So subtracting the two electric fields, let's try to find the answer to that. finding the answer, you would get 127,658,000 newtons. So you would get this as your final answer. So that would be closest to letter D. So the answer to number 13 is going to be letter D. Number 14. Two 4.88 meter long wires are parallel to each other and they are 1.28 centimeters apart. Each wire carries a current of 62.4 amps in the same direction. Find the force of attraction between the two wires. So let's draw it out. We have two wires. Both are 4.88 meters long. There are 0.0128 centimeters spaced out. Both carrying 62.4 amps. I'll put that in red. So they're both carrying a current of 62.4 amps. And because they're both carrying a current, there's going to be an attractive force between the two. So there's going to be an attractive force. We know the formula for attractive force in a wire, between a wire and a point. The formula for the attractive force is current times the length of the wire times the strength of the magnetic field. So, and we also know that the strength of the magnetic field, using a variant of Ampere's law, is equal to the permeability of free space times the current through the wire over 2 times pi times the distance between the wire and the point. So that would be, if you have a wire and you have a point, you're trying to find the magnetic field at the point. So the magnetic field. Plugging this part into letter B, you would get, referring to this as I2 and this is I1 to make it easier, you would be getting the permeability of free space times I1 times I2 times L over 2 pi r. Plugging this equation into B. So force equals, permeability of free space is a constant given to you on the formula sheet on the exam. It's 4 pi times 10 to the power of negative 7. So 4 pi times 10 to the negative 7 times I1, the first current is 62.4 amps. The second current is 62.4 amps. And the length of the two rods, L is the length. The length of the two rods is 4.88 meters. Over 2 pi r, the radius is the distance between the two wires, which is 0.0128 meters. Plugging everything in to a calculator, you're going to get you're going to get 0.297 amps. I mean, not amps, newtons. So the answer to this question is going to be A, 0.297 newtons. Number 15. A metal rod makes contact with two parallel wires that are 12 centimeters apart and completes the circuit. This circuit is perpendicular to a 0.858 Tesla magnetic field coming out of the page. If the resistance is 6.06 ohms and a 53.1 millinewton force to the right is applied, at what constant speed will the rod move? There are a couple of formulas you're going to need to know for this question. When a magnetic field is directed through a current of wire, a loop of wire with a rod in it. The induced EMF, or the induced voltage, is equal to the strength of the magnetic field times the length of the rod times velocity. So induced EMF, also known as induced voltage, L is length of the rod, and V is velocity of the rod. So let's move everything to the side a little bit. So we know that this rod has a force of 53.1 millinewtons. And it has 6 ohm resistance. So there's going to be a resistor of 6.06 ohms. Using the Ohm's law, voltage equals current times resistance. Remember, voltage is the same thing. Induced EMF is the same thing as voltage, induced voltage. So we can replace that with induced EMF. Induced EMF equals current times resistance. So how do we find current? Well, we're given resistance is 6.06. So we're given resistance. How do we find current? Well, we know that because there's a magnetic field going through the rod, there's going to be something called an induced current. If a magnetic field is going through a wire, so let's say this is the magnetic field B. By the way, B stands for magnetic field. And I'll make that the magnetic field in blue. I'll make the current going through the wire red. So let's erase that for a second. With that in mind, there's going to be an induced force. The force is equal to the current times the length of the rod times the magnetic field times sine of theta. So what is theta? Theta is the angle between the magnetic field and the current. So in this case, since it's perpendicular, theta is 90 degrees. So this would be ILB sine of 90 degrees. And sine of 90 degrees is equal to 1. So we can actually remove ILB of the sine theta altogether. So we're just going to be left with force ILB. So in this case, the magnetic field will be perpendicular. So you would get a right angle. But now what do we do? Well, we know the force is equal to 53.1 millinewtons, or 0.0531 newtons. We're trying to find the current because we're trying to find the current over here. So current times the length of the rod is 0.12 meters. We're given that the wires are 12 centimeters apart. So the length of the rod is essentially 12 centimeters. And the magnetic field is 0.858. These are the two formulas you'll need to know for this question, by the way. Just to summarize. So solving for current here, you would be getting 0.530. This is actually a 1 out of 7. 531. 0.531 divided by 0.12 divided by 0.858. Current is equal to 0.516 amps. 0.516 times the resistance. You would get induced EMF as 3.125 volts. That's the induced EMF right here. Now plugging the induced EMF into the top formula we got over here, what do we have? We have, I'll move this down a little bit. We have 3.125 equals, the magnetic field is 0.858. The length of the rod is 0.12 meters. And we're trying to find velocity. So divided by the answer by 0.858 divided by 0.12. Velocity becomes 30.355 meters per second. So the closest answer would be E, 30.4 meters per second. So the answer to number 15 is going to be E. Number 16. A 20-inch candle is placed 36 centimeters from a converging lens with a focal length of 24 centimeters. Describe the image. So there's always going to be one optics question on the test. So we know that we'll draw the candle. So my best drawing right there. The candle is 2 inches. So if this is placed 36 centimeters away from the converging lens with a focal length of 24 centimeters. So focal length right here is 24 centimeters. The height of the candle itself is 2 inches. So the formula to find so we know that this will result in an image. If you bend the light rays, I'll use blue as light rays. The light rays will bend towards the focal length. The light rays here will bend towards the focal length. And this convergent point right here is the image. The height of the image. So right here, that's the image. So let's draw it out. What is the formula to find the height of the image? The distance between the image and the lens. This is the formula. 1 divided by focal length equals 1 divided by the distance between image and lens plus 1 divided by the distance between object and lens. So F is focal length. DI is image distance. DO is object distance. So let's plug in the values. The focal length is 24 centimeters. In optics, in this case, we actually don't need to convert it into meters. This is probably the one time we don't need to convert it to meters. It's a bit like your answer will stay the same regardless of if you do it centimeters or meters. We're trying to find the distance of the image plus 1 over the object is 36 centimeters from the converging lens. So the focal length is 24 and the distance between the object and the lens is 36. So solving for DI, you would get 72 centimeters. So it turns out this image would be 72 centimeters away from the lens. Be all the way over here, actually. It's a slightly inaccurate drawing of the image. So the image would actually be all the way over here. Chances are it's probably going to be reflected downwards. So the image is all the way there. Now to find, so because DI is positive, if DI is positive, it's a real image. If DI is negative, it's virtual image. So it cannot be virtual, so you can eliminate D and B. Now, what do we do from that? We find the magnification. It's negative DI over DO. DI is, we found out as 72. DO is 36. So the magnification is negative 2. If the magnification is greater than 0, it's erect. If the magnification is less than 0, it's inverted. And the final condition is that if the absolute value of the magnification is greater than 1, then it's enlarged. And if the absolute value of the magnification is between 0 and 1, it's reduced. These are all the things you have to memorize if you want to do the basic optic questions. One more formula that you're going to need to know that you won't need to know here is magnification is equal to the image height divided by the object height. So since the magnification is -2 and the height of the object is 2, the height of the image would equal -4 inches, meaning it would be 4 inches downwards. This would be 4 inches. So, okay, I was going a bit ahead of myself. Is it erect? Is it inverted? Is it enlarged? Is it reduced? So let's look at erect and inverted first. The magnification is -2, which is a negative number, so it has to be inverted. So we can get rid of all three instances are inverted. And what about enlarged and reduced? And the absolute value of -2 is 2, and 2 is greater than 1, so the answer has to be enlarged. So the answer to number 16 is going to be C. Number 17. Haley and Hannah are twins. Both were 22 years old when Haley volunteered to take a journey on the Starship US Bulldog. On the Bulldog, she traveled at nearly constant speed. When she returned to Earth, she claimed to be 28 years old, while Hannah knew they were both actually 40 years old. If the Bulldog had an accurate clock, the Bulldog must be traveling at some number times the speed of light. So this is a problem regarding time dilation. The formula for time dilation is going to be the actual time equals the observed time over the square root of 1 minus velocity over speed of light squared. So where t, the t without the 0, is the actual time. TO is observed time. V is velocity of the ship, which we're trying to find. V is what we're trying to find. So speed of light. So what is T and TO? So we know Haley claimed to be 28 years old, and they were initially 22. So 28 minus 2, Haley claimed 6 years has passed. So 6 years is the observed time. That's what she claims. 1 minus V over C squared. But how much time has actually passed? So Hannah knew that they were both 40 years old. So 40 minus 22 would be 18. So 18 years was the time that actually passed. So even though Haley thought 6 years passed, that was her own observed time. Hannah knew that 18 years was the actual time that passed. So rewriting the equation, you're going to get square root of 1 minus V over C squared equals 6 over 18. So 1 minus V over C squared equals 1/9. V over C squared equals 8 over 9. V over C equals 0.943. Make that neater. 0.943. That means velocity has to equal 0.943 c. So the answer to this question is 0.943 c. In this case, it'd actually be a rounding, because the answer is 0.942, so this would have just been a rounding mistake. But the answer to number 17 is still going to be B. Number 18. Consider the beta decay reaction. where krypton breaks down into rubidium, an electron, and a certain symbol. So what is this symbol? This is just a memorization question. You just have to know all the symbols for each of these. For a neutrino, the symbol is just a V. For a Higgs boson, the symbol is an H. For a gluon, the symbol is a G. Photon, the symbol is a Y. Well, actually, it's like a Y shaped. It's a Greek letter that looks similar to a Y. Something like that, kind of. And an antineutrino would be a V with a dash. Whenever you see the word anti, there's going to be a dash on top. So in this case, neutrino would just been the V. The dash on top would mean anti. So the answer for number 18 would be letter E, antineutrino. Number 19. Luke needed to find the coefficient of sliding friction for the inclined plane in his AP Physics class. He releases a 0.678 kilogram block from the top of an inclined plane and then noted the acceleration of the block as it slid down the inclined plane. He repeated this procedure for several angles. He plotted the data in the table above. Use a table to find the coefficient of sliding friction for the inclined plane. So let's visualize this diagram. You have an inclined plane like this, and you have a block. So you have a block right here. Hold 1 sec. There. So this block is sliding down the plane that has friction. This plane has friction. Let's first start like every single one of these physics 1 problems and jot down all the forces. We know there's a weight force and there's a force of friction. Those are the 2 forces that are acting on this block, weight and friction. However, let's simplify the weight a little bit more. Let's break the weight. Okay, so first of all, let's draw a line like this so that it can show that the angle of inclination. And then let's draw dotted lines like that and like that, such that this would form a right angle. If I bring this triangle outwards, just to have more space to draw, I would have something like this, where the black arrow would be the weight. Weight is equal to mass times gravity. The angle between the black arrow and the red arrow is actually going to be theta. It's actually a property of triangles. It's because of similar triangles. It's more of a geometry concept. But basically, this angle between the black and the red line is theta, the same angle of inclination that we talked about before. So the blue line would be mass times gravity sine theta, and the red line would be mass times gravity times cosine theta. This is just trigonometry. I'll explain it for cosine theta. Let's just say cosine theta, the red line is equal to x. So cosine of theta is equal to adjacent over hypotenuse, x over mg. X would be equal to mg cosine theta, which is why mg cosine theta takes place of x. Mg cosine theta. Now, what is all this? This blue arrow that I just drew is the weight component. This is the blue arrow is what's pushing the block downwards. And we know that the force of friction is opposing it. So the blue arrow is the weight component, one component of the weight. And the green arrow is the friction. What about the red? The red arrow is equal to normal force. Because remember, normal force is what opposes the weight force. But in this case, since it's on an incline, it's not on a flat plane, normal force and weight force do not equal. That's one big conception you need to know, is that they do not equal because the plane is slanted. So, we want to find net force. Because remember, acceleration equals net force over mass according to Newton's second law. So what is net force? That is the weight component minus the force of friction divided by mass. The weight component is mg sine theta. the force of friction is, remember, the formula for friction is equal to coefficient of static friction times normal force. Or coefficient of friction times normal force. And normal force in this case is mg cosine theta. So plugging everything in, you would get something like this. Coefficient times mg cosine theta divided by the mass. You can cancel out mass to be left with g times sine theta minus coefficient times cosine theta. So that's the final expression you can use. G times sine theta minus coefficient times cosine theta. We're trying to find the coefficient of friction. We know G is 9.8, and acceleration and angle are given to us in the graph. So let's just take a random point. Let's just take this point here. 0.9 radians, comma 5.5 meters per second squared. So plugging that in, 5.5 equals 9.8 times sine of 0.9 minus coefficient of friction times cosine of 0.9. Plugging everything in, trying to solve for coefficient of friction. That's our goal. Let's move this downwards. So 5.5 divided by 9.8, you would get 0.561 equals sine of 0.9 minus coefficient times cosine 0.9. So move that. Now you're trying to isolate the coefficient. So you're going to get coefficient equals 0.561 minus sine 0.9. Or actually, no, the other way around. Just redraw it. Sine of 0.9 minus 0.561 divided by cosine of 0.9. Plugging everything in, you would get coefficient of friction equals 0.357. The answer, and you're trying to find the closest answer in this case, because keep in mind that this is kind of an estimate. This is not the actual point. 0.9 and 5.5 is not the actual point. So you want to take the closest value, which is going to be B. So for number 19, the answer is going to be B. Number 20. The switch is closed at t equals 0. Find the charge on the capacitor at t equals 0.024. So this is an RC circuit. This is known as an RC circuit, meaning resistor capacitor circuit. So here's some formulas you're going to need to know. The first one is, in an RC circuit, the final voltage in the capacitor equals the initial voltage in the circuit times 1 minus e to the negative t over the time constant. I'll make that a little bit neater. T over time constant. So VF/I, that is final voltage. So VF is final voltage, VI is initial voltage. T is time. And capital T is time constant, which I'll go over later. Time constant is equal to RC, where R is resistance in ohms
and C is capacitance in coulombs. So, final voltage equals, initial voltage we know is 60. 60 times 1 minus e to the negative, t is 0.024. What is time constant? Time constant is resistance times current, capacitance. Resistance is 120 ohms, capacitance is 200 microfarads. Micro is 10 to the negative 6. So 120 times 200 times 10 to the power of negative 6, you would get the time constant equals 0.024. 0.024. So let's move that down a little bit. So the final voltage, if we plug everything in, final voltage would equal 37.927 volts. But we're not trying to find the final voltage, are we? We're trying to find the final charge on the capacitor. So we need to find we need to use another formula for this one. Charge on a capacitor equals the so we know the time constant. Let's erase this for a second. Charge on a circuit equals capacitance times voltage. So Q stands for charge, C stands for capacitance, and V stands for voltage. So we know the final voltage is 37.927 and the capacitance is 200 microfarads. So just plugging everything in, so Q equals 200 microfarads, which is 10 to the negative 6, times 37.927 volts would give you 0.007585 coulombs, because we're trying to find charge. But we want to find the answer in millicoulombs. We know to convert coulombs to millicoulombs, to find this many coulombs, to convert that into millicoulombs, we have to multiply by 1,000. So multiplying the number by 1,000 would give you 7.585 millicoulombs. That is our final answer. 7.585 rounds to 7.59. So the answer to number 20 is going to be C. And we're done with this exam. All 20 questions. And if you had started from biology to chemistry to physics, you would have been done with the test by now. The entire test, all 60 questions. So I hope you found this video useful, and I hope you understood many more different formulas than concepts you would use in this exam. If you liked what you learned from this video, feel free to like and subscribe, and make sure if you have any doubts, any questions that you want to ask me, leave it down in the comments and I'll be glad to answer them. I hope you enjoyed this video, and I'll be seeing you guys when I make my next virtual challenge meet.